So in this chemical equation, we have aluminum hydroxide reacting with carbonic acid and producing aluminum carbonate along with water. One of the polyatomic ions that we have is hydroxide. It only appears in the reactant side. It does not appear in the product side. So with that being said, I'm going to break it down into oxygen and hydrogen. The next polyatomic ion is carbonate. It appears one time in the reactant side and it appears one time in the product side. So I'm going to keep it together. I'm not going to break it down. So let's go ahead and get started by determining how many atoms and polyatomic ions are present in this chemical equation. We have one aluminum. We have 3 oxygens. We have a total of 3 plus 2 gives me 5 hydrogens, and then we have 1 carbonate. On the product side, we have 2 aluminums. We have 3 carbonates. We have 2 hydrogens, and we only have 1 oxygen. Now, we need to identify the loner. The loner is the one that is not part of a compound. In this chemical equation, we do not have it, so we're going to skip this step. The next step is to identify the 1:1 ratio, also known as the pair element, and that is the one that appears one time in the reactant side and one time in the product side, and it does not matter if the subscripts are different. So aluminum appears one time in each side. Oxygen, it appears one time. Hydrogen, it appears 1 and 2 times, so it's already a no. Carbonate, it appears 1 time. So next we need to start with the largest 1:1 ratio. And this is the element that has the largest subscript. So notice that oxygen has a subscript of 3, or there are 3 of them, we should say, and there are also 3 carbonates. So in this specific situation, it's best to start with the polyatomic ions. So we have 3 carbonates in the product side and 1 carbonate in the reactant side. So I want to have 3. So I'm going to come here and I'm going to write a coefficient of 1. 1 times 3 gives me 3. So therefore I need to have 3 over here. So I'm going to come here and write a coefficient of 3. So now we have 3 carbonates. I'm going to continue with this compound because this 3 is going to make a change for the hydrogens. This 1 is not going to make too much of a change for the aluminums. So 3 times 2 gives me a total of 6 hydrogens plus 3 from here gives me a total of 9. Now, we have a total of 9, but notice that we have not written anything here for the coefficient. So the minute that I write something in here, this number is going to change, the number of atoms for hydrogen. So I have a 2 over here. So it's best to try to make this odd number into an even number, so that way when I come over here, I can make it an even number. So what I'm going to do, I'm going to say 3 times 2. So now this is what we have. I'm going to write my 2 better. We have 2 times 3 for our hydrogens plus 3 times 2. 2 times 3 is 6. 3 times 2 is 6. 6 plus 6 is 12. So I need 12 hydrogens in the product side. How do I do that? I write a coefficient of 6. 6 times 2 is 12. And then at this point, we have balanced everything. but let's double check. So let me erase this first. We have 2 aluminums. 1 times 2 gives me 2. That's good. For our oxygens, we have 2 oxygens. Correction, 3 times 2 is going to be 6. And then on the product side, we also have 6 oxygens. And then we already talked about the rest. 12 hydrogens, 3 carbonates. So therefore you should have 2, 3, 1, and 6.